electronic configurations of elements. An electron in an atom is characterized by a set of four quantum numbers, and the principal quantum number defines the main energy level known as the shell. The filling of electrons into different subshells, also referred to as orbitals, s, p, d, f in an atom. The diagrams of the different types of orbitals are shown. Keep on clicking on the next button to see all the different types of orbitals. The distribution of electrons into orbitals of an atom is called its electronic configuration. An element's location in the periodic table reflects the quantum numbers of the last orbital filled. Group-wise electronic configurations. Elements in the same vertical column or group have similar valence shell electronic configurations, the same number of electrons in the outer orbitals, and similar properties. The elements of group number 1 along with their electronic configurations are as shown in the following table. The connection between the electronic configurations of the elements and the long form of the periodic table. Electronic configurations in periods. The period indicates the value of n for the outermost or valence shell. It can be readily seen that the number of elements in each period is twice the number of atomic orbitals available in the energy level that is being filled. The fourth period, that is when n is equal to 4, starts at potassium and the added electrons fill up the 4s orbital. Now you may note that before the 4p orbital is filled, filling up of 3d orbitals becomes energetically favorable and we come across the so-called 3d transition series of elements. This starts with scandium, which has the electronic configuration 3d14s2. The 3d orbitals are filled at zinc with electronic configuration 3d10-4s2. The fourth period ends at krypton with the filling up of the 4p orbitals. Altogether, we have 18 elements in this fourth period. The sixth period, that is for n equals to 6, contains 32 elements and successive electrons enter the 6s, 4f, 5d and 6p orbitals. In the order, filling up of the 4p orbitals begins with cerium and ends at lutetium to give the 4f inner transition series, which is called the lanthanoid series. The seventh period, that is for n equal to 7, is similar to the sixth period with the successive filling up of the 7s, 5f, 6d and 7p orbitals and includes most of the man-made radioactive elements. This period will end at the element with atomic number 118, which would belong to the noble gas family. Filling up of the 5f orbitals after actinium gives the 5f inner transition series known as the actinoid series. The 4f and 5f inner transition series of elements are placed separately in the periodic table to maintain its structure and to preserve the principle of classification by keeping elements with similar properties in a single column. Group-wise electronic configurations. Elements in the same vertical column or group have similar valence shell electronic configurations, the same number of electrons in the outer orbitals and similar properties. The elements in a vertical column of the periodic table constitute a group or family and exhibit similar chemical behavior. This similarity arises because these elements have the same number and same distribution of electrons in their outermost orbitals. We can classify the elements into 4 blocks: S block, P block, D block and F block depending on the type of atomic orbitals that are being filled with electrons. We notice 2 exceptions to the categorization. Strictly, helium belongs to the S block, but its positioning in the P block along with other group 18 elements is justified because it has a completely filled valence shell 1s2 and as a result exhibits properties characteristic of the other noble gases. The other exception is hydrogen. It has a lone s electron and hence can be placed in group 1 alkali metals. It can also gain an electron to achieve a noble gas configuration, and hence it can behave similar to a group 17 halogen family elements. Because it is a special case, we shall place hydrogen separately at the top of the periodic table. Question: how would you justify the presence of 18 elements in the fifth period of the periodic table? Solution: when n equal to 5, L is equal to 0, 1, 2 and 3. The order in which the energy of the available orbitals 4d, 5s and 5p increases is 5s less than 4d is less than 5p. The total number of orbitals available are 9, and the maximum number of electrons that can be accommodated is 18, and therefore 18 elements are there in the fifth period.